So let's begin with one of the last lectures. We have guest Tonimir Kišasondi. He'll give a brief lecture on screw-ups in app security. And yeah, let's give him applause and thank you.
So, hello. Thanks for the introduction, definitely. I had to fiddle a little bit with my machine because getting some of my stuff to work is usually a chore. So, for those who know me, it's quite nice to see some of my former students in the audience, and it's always nice to go down the memory lane. I was a former assistant professor at FOI. Since the evil professor vibe is not all that, I decided to try the international mercenary route. So, here we are now. I lead a small boutique application security shop called Oru. We focus exclusively on application security and IoT security with architecture reviews, development, security reviews, either on low-level side of code reviews, technical reviews, and trainings, of course. So, what will we talk about today? We will talk about the current threat landscape for application security vulnerabilities. Some of the stuff we currently see that is very good, that you can use today to help you secure your applications, and also some of the bad parts, what currently people are not paying attention to. So let's start. Landscaping, yeah, because it's called, if you look technically, it's called variant analysis. That means you get to look at what usually gets popped in the wild, what kind of attacks people use, how are other companies getting owned, and then you can use this to improve your defenses. So this is one of the most important things if you want to improve security somewhere. Start doing variant analysis. And if you want to see what are the current threats in application security, I would highly suggest you take a look at HackerOne and Google, and let's see what they say. First off, HackerOne is a bug bounty platform, but they have a ton of statistics regarding what kind of bug bounties get reported to them. So it's biased for bug bounty hunters, but when you look at this, you will see that cross-site scripting, information disclosure, improper access control, privilege escalation are pretty much the norm today. These are the top 4 bugs. Yes, OWASP top 10 paints a different picture, but this is what we're dealing with. The second one is from Google. Google says at least 35% of their bugs are cross-site scripting. The rest are non-web issues, mobile app vulnerabilities, business logic vulnerabilities, and misconfigurations. Business logic vulnerabilities are a favorite of mine, because if you dive in how this business process should work, and then you see what kind of malicious stuff you can do, usually you get to some epic levels of breakage, which are usually flabbergast people. How did you do this? How did you figure this one out? Well, let's see a little bit. First off, some info about the good parts. Platform security is really getting better. So if you look at the modern web browser, if you look at the modern application server, if you look at the modern tooling, everything is really getting better. You have a lot of things. First, let me tell you about a new thing that's happening in the last 2 years that's called same-site cookies. How many of you know about same-site cookies? No one. 1. Amazing. So one. Okay, that's cheating. You're from security, so so same-site cookies are a recent addition to all cookie flags. You all know about cookie flags. There's HTTP only. There's secure. HTTP only won't let JavaScript access your cookies from JavaScript. Secure will only pass the cookie if it's over HTTPS. Now we have a new one called same-site. What does same-site mean? That means that the cookie will not be sent for any request unless the request is from that application's browser tab. So cross-site request forgery works in a way that you visit a site, your application is vulnerable to cross-site request forgery, and that site will issue a request for your browser in the name of your browser. So you will say oru hejar delete user 1. Your browser does not know that this was not executed by you, but with a piece of JavaScript, so it will get executed normally. Same site prevents this. If you are not on the same site, if you are not on the browser tab where this should normally be, same site will block this. There are 2 ways. One is lax, which will still work if you press on a button, and they're strict. Cookies will only be sent or will be available in a specific browser tab if the location is the same as the same site as the site requests. You can read more about this on Mozilla's page, but why is this important? Because from Chrome 80, that's close by, Chrome 80 will have same site legs by default. Soon this will also land in Firefox. By soon I mean in the next 6 months, 8 months. So yay for making cross-site request forgeries a bit difficult. Why should you care? Because this feature literally takes, I don't know, 30 minutes to implement in your sites, in your applications, and check out the same site tags. Try to implement it. See if it breaks your application. If it doesn't, a whole class of vulnerability, that's request forgeries, the cross-site request forgeries, which are pretty important, just got wiped out. Check it out. You'll be surprised. Second thing we have is something called Content Security Policy version 3. It's also new. It's a lot. Like, this could be a lecture on its own, but I just want to raise awareness about some of these new technologies in your... So if you are watching this talk, and you can then look at your organization, can I implement something of that? That's why I left the links from Weisselbaum and the Google developers update on trusted types. How does it work? Simply. Each request will send a header, content security policy, script source, nonce, and some random value, and the keyword strict dynamic. And in your code, any piece of JavaScript that wants to be executed, your application needs to have the exact same nonce as content security policy, nonce that is sent in the header. Why is this even important? Because if somebody wants to inject a piece of JavaScript in your application, he needs to know the nonce. Since he doesn't know the nonce because it will be generated on each request, well, you just wiped out a whole level of cross-site scripting vulnerabilities. Don't believe me? Google did a research on this, and they said that about 60% of cross-site scripting vulnerabilities got eradicated when they implemented this. So cross-site scripting is a big problem, 35% of all reported vulnerabilities, and you can do a lot of it. So it's very easy. I won't go into details, because if I go, this will be like a 1-hour talk, but you can easily implement this today. So check it out. Content Security Policy version 3, not version 2. Also, we see a lot of cross-site scripting. There hasn't been a penetration test or a security review that I've done that I usually just have a chapter called cross-site scripting, and then just like taxatively number where I found that vulnerability. So in a nutshell, what's the problem here? So you have your browser. Your browser is not a simple machine. So your browser has a HTML parser. It has a CSS parser. It has a JavaScript engine. Does anybody know what other parsers in your browser are? SVG, MetML, like any other plugin you have. So it's a very complex dance of various parsers that will generate and render content for you. And when you give them a specific piece of data, what will happen is if you give them broken pieces of data, so you start with an SVG image, but then you start writing JavaScript, but then you start writing some CSS, the browser will be very confused in what to do. And what does the browser do? If the parsers were strict and they would simply drop the data and say, this is garbage, this is bullshit, I don't want to execute this, well, half of our web wouldn't work because people write broken code all the time, right? But what the browsers do is they try to figure out what would be the most sane way to render this. And here we are with the security telling us this is a bad thing. What happens then if you mix various types of data formats? If you start doing them, the browser will mutate them out. So you will have outputs that are not very, how should I say, logical. For instance, this is an XS polyglot. It's a piece of JavaScript that if you look at it, you see that it has a mixture of various tags, text area, script, XMP, SVG, onload, onmouse, over, and this will pass a lot of XSS filtering and XSS output encodings. So you can execute if you drop this in any part of the application that doesn't do proper output encoding, you can pretty much execute arbitrary JavaScript that you can place instead of alert 1. This is an example from Garrett Hayes. If you like to know more about technical details of JavaScript and XSS, follow Garrett Hayes and other researchers like Masato Kinugawa, who have pretty great research in that part. So what will your browser do? He'll take this, he'll try to fix it, and it will end up in JavaScript, and you will execute JavaScript in the browser tab of the user, which is very bad. If you use something called client-side sanitization, I know, people will tell you, never sanitize client-side code. But for cross-site scripting, for JavaScript, there is no way you can sanitize JavaScript in the backend. You need to do proper output encoding. So depending on where you drop your raw content, you need to do proper output encoding. But what's even more difficult, that output encoding depends on your parsers. So what we have here is something called DOM Purify. DOM Purify is a client-side sanitizer for JavaScript. You can just load it like source type text JavaScript, load DOM Purify minimized JS, and then you can just do DOM Purify sanitize anything dirty, and it will, for instance, for this piece of malicious JavaScript, it will render as proper empty SVG code. This is very easy to implement. If you have problems, I know security people are kinda persistent and boring. And I know that you do not wish to, sorry for the security people in the audience, but usually when we tell you, fix this cross-site scripting, if you don't know how, take a look at DOM Purify. You can implement it in client-side. You can wrap insecure pieces of text in it or code, and you will have way more success in filtering cross-site scripting, okay? Do not try to filter cross-site scripting. I see this all the time. People try to filter. So what one group did was they saw that certain attacks were getting through their filtering. So they look at the logs for a vulnerability scanner and they patch the cross-site scripting vulnerability. And this was pen tested by a security company who said there is no cross-site scripting vulnerability here. But if you use, for instance, if you have your own XSS vectors, like the mutational XSS ones, what will happen is those will still pass and execute JavaScript. So when you ask them, how did you patch this XSS? They'll say, oh, we created a filter. So on alert, alert 1, on error, alert 1. So if you had alert 1 in the code, alert XSS, alert document cookie, it automatically blocked that content. Filtering never works. You cannot have security by filtering, like specifying known bad occurrences. You have to specify known good occurrences if you want to use this. So keep in mind, you can fix a lot of this with, if you use DOM Purify, also refer to the OWASP cheat sheet on XSS. And then after that, you can think about content security policy and so on, and you will have a lot of success in eliminating cross-site scripting. This is a bane currently, and this is a very simple solution for that bane. 5 years ago, we didn't have platform security features. Why? Because browsers were complex, and now browsers are the next operating system. When you look at Chrome OS, when you look at stuff that's happening there, they have to have security features to prevent such problems. So I would highly suggest you start looking into same-site cookies, content security policy version 3, trusted types. I didn't even go into this because I don't know how to. This is also very intense on content, but I don't know how to explain them in like 3 minutes. And client-side XSS sanitization, check those out. They will be very useful for you. Every year, something new comes along regarding platform security. Get to know it, implement it. It's quite easy to implement, and you will raise the bar significantly higher for your attackers. And now the ugly stuff. You can't have beautiful without the ugly, right? So let's start with some problems that we also see in the wild. First off is two-factor authentication. So what's the problem with two-factor authentication? SMS-based two-factor authentication needs to die in a fire right now. This is the worst piece of security ever that is currently available. When I ask people, oh, Why do you hate SMS two-factor authentication? People are, is it because like if you pay 500 euros to a shady telecom in I don't know, some African country or some backwater Eastern European hellhole, you can get SS7 access? And what is SS7? SS7 is a routing protocol. And the way GSM works, like the whole mobile networks and everything, is that this is a simplification. Don't jump at me if you know how actually SS7 works. So you can tell them, oh, by the way, the phone number you want to send an SMS to is totally changed, so you should use this phone number. You should send SMS to this phone number. You can reroute SMS, you can reroute calls, and this is pretty easy to do. You can use like OpenClip, you can fake phone calls from other people. It's amazingly hilarious to do that to your friends. They at least figure out that you're joking with them. But unfortunately, this is used for fraud a lot. And people think, yeah, okay, you can pay 500 euros and somebody can reroute your SMSs. But the bigger problem is something we saw with Twitter. If you have SMS for password resets, for instance, you can get a password reset token to your SMS, or you can use the service with the help of SMS. A lot of telecoms will have zero problems. Don't ask me how I know this, but a lot of telecoms will simply issue you a new SMS. For instance, if your wife decides to buy you a new iPhone and wants to surprise you with a new phone and calling you on that new phone. So, unfortunately, SIM swapping works in the area of petty criminals. You can get a non-technical person to social engineer somebody in a store, in a telecom. Oh, I lost my phone, or I want to surprise my boyfriend or my husband. Can you swap this SIM? And also, like any store clerk can do this. So we are relying on authentication that is non-existent. Unpopular opinion, you would be served by email-based two-factor authentication where you get a link and you can click a link better than with SMS. So please stop using two-factor SMS if you can. But if you don't have anything else, it's still better than nothing. And why do I say like TOTP has the same problem? If you can social engineer somebody out of a password, if you can steal his password, you can totally steal his token. This is a phishing page that will correctly steal two-factor authentication tokens and will correctly verify if you enter the correct password. How does this work? It's a tool that's currently being used in the wild a lot. It's called Evil Nginx 2, which is a proxy. It's not a phishing portal. So it will be a proxy that will proxy your connection. It will have a valid SSL certificate on one end. On the other end, it will have it will fake content to a server, and your server will think, oh, a user is communicating with me. But when the whole exchange is done, with TOTP, with SMS, with whatever, your that phishing proxy will just drop the cookies or the authentication tokens for the access, and your attacker can access your stuff. There are three popular ones. Credential Sniper from, I think it's Black Hills InfoSec, but don't quote me on that. Evil Nginx 2 and Modlishka, which are very interesting phishing projects. The only way you can fix this is by using security tokens. U2F, you know, the little keys on the keychain. Why? Because they both authenticate. So how do they work? When you enroll them, the token will enroll the name of the server, so the server's URL. It will enroll it into the token and generate a public key and a private key. The private key will be stored in the secure element of the token. The public key will be given to the server. And the second verification step, the server will generate a random challenge, send it to the key, and he will sign it and return the random challenge. So this prevents replays. But the other interesting thing that people forget is that the origin and the channel name and everything will be sent to the token. So the token also verifies the server, the URL, the host that's requesting the U2F token. So if you want to phish this, you cannot phish this because your browser will say, oh, the document, okay, it's a simplification, but the document location is this. It's the phishing page. It's not the original page. So use U2F tokens. They are really helpful. You can enroll multiple tokens, like three or four of them. You can have backups. And this helps with two-factor authentication, unfortunately. Also, they by default identify the server, they by default identify the client, so they're way better option than using SMS. Stop using SMS if you can. If there isn't choice, rather use TOTP, which is kind of fine, but still can be phished. If you have an option for universal second factor of FIDO2, please use that. I know a token costs $18. It's expensive, but it's still better than all of those if you can support that. The second thing that's commonly broken is authorization. If you don't know what to find in a penetration test, usually you just go to the authorization route and you'll find a lot of stuff. So this is a common thing a lot of you know about insecure direct object references, right? So you have something like an API or an endpoint or a form or something, and you can say api.something.com invoice 123, and you will get the invoice that's number is 123. What happens if you change it to 4 or 5 or 6? Sometimes, if you're vulnerable to direct object references, you can get other invoices that you don't have the permission to access. Same applies to JSON, same applies to XML, same applies to EDI. Who knows what EDI is? One. I'm sorry. EDI, Electronic Data Interexchange. It's like, if you thought XML was bad, there is like a lot of arcane protocols that you are like, people use this? Goddamn. So, even more fun, what happens if you start entering -1, maximum integer, maximum unsigned integer, hexadecimal values, octal values? Stuff tends to get very weird very fast. And this is pretty simple. Attackers change this all the time. The first thing you need to know about web hacking is that people do not rely on their web browser. They have an intercepting proxy that sits between the browser and the client, and then they can change any request. It doesn't matter if it's in HTTPS. If the request is coming to your attacker's machine, that's why mobile security is also a problem, because the device your attacker has, he can change anything he wants on it. You are receiving content that the attacker wants you to receive. So, what happens here? What happens if you have an additional parameter? You have API something com invoice 123, and then you have a parameter export to CSV. This is a usual place where I see, like most of the time, authorization is broken here. Direct object references won't work if you just do invoice 123, then you change it to 456. But if you start adding parameters, if you have export to PDF, to CSV, to something, here everything tumbles down. Any place where you have layered logic in an application, by my experience, is just a very brittle point that just waits to be broken. So keep that in mind. Sudden resources might become suddenly available. More layers or more edge cases can become available, and it's a problem. Why? Because people think, well, how does this application react to partial data? What if I give it a part of the request? What if I get creative? So analyzing business logic is the key here. And people think this is difficult for an attacker to figure out. This is just like day after yesterday's something I was doing. An attacker has a tool that will help him. So he can add a user, he can serve a session as user A in his browser. He can add a token or a cookie, for something for user B, and his tool, his intercepting proxy, will create a new request for every request with a second set of cookies, tokens, headers, everything mimicking the second user. And you have this little nice, this is enforced and okay for the user, but the yellow parts are where the authorization is broken for the second user. So when you think that this is something that's not common, this is very common. This is usually in the wild a big point of, like a big no-no. So if you have authorization in your applications, please do check authorization. The last thing, since we have less than 5 minutes remaining, is Json Web Tokens. I hope you all know about JSON Web Tokens. They're a signed set of claims, and you have a specific set of claims. And they are, you get those claims, you do base64 URL encode them, separate them with a dot, and the last third part is the signature. There are lots of issues with Json Web Tokens. One is wrong storage. If you use local storage, they can be easily stolen. There are like different library issues, algorithm confusion, but one interesting point is this: invalid recipient attacks and same recipient attacks. Like, I don't know, maybe I'm biased, but usually people don't get this right. So if you have, for instance, a microservice architecture, what happens if you have a workflow set that you know how you want your workflow to occur, but then the attacker uses the same JOT token instead for your organization, for a second organization, or for a second service? Usually people will verify, is the token okay? Is the subject okay? But they will not verify, is the audience of the token okay? The second thing, also like different subparts of the operations, you need to check both the subject and the audience for a JOT token. Please verify if your tokens that you use can be used on a specific system, and they should be used on that system. If you don't verify that, an attacker will take your token and happily bring it to another system. Yes, I'm logged in as user something for a user portal, but I'm going to use that same token from the user portal, and I will try logging into a like an administrative portal, a self-service portal, anything else. So keep that in mind. I cannot talk about specific cases, which would be very, how should I say, straightforward to give you an example, but keep in mind, check the audience for your token, where it can be used. Yes, you should use JOTs. You should use them for transitive identity verification. They do not replace cookies, but keep in mind, some of these things can go really badly. Get to know, so for the conclusion, we have, I think, 3 minutes left or 2 minutes left. Get to know specific platform security features. Leverage your platform to protect your users and yourself. Second, logic bugs, business logic bugs, are the next big thing. Think about your business process. Think about what can go wrong if somebody changes something in this business process. When you start thinking about that, trust me, new cool bugs will emerge and you will find outliers in your system where something can go wrong. And start implementing variant analysis into your processes. If that's like banking sector does it really good. If a threat actor is owning X institutions with the same method, everybody else should protect themselves for similar attacks. Same thing here. If you look at how, for instance, I like to look on HackerOne, how people are finding bug bounties, and you can see like somebody finds a server-side request forgery on variant XY of application, and you can see them just like 40 reports of the same vulnerability, same class, just reiterated on other organizations. So you can learn from this. It says 28 minutes, 10 seconds. We have 1.5 minutes left for questions. Questions? Yes.
What I often get. Thanks. Okay, so one thing that I got a lot of from developers is regarding insecure direct object referencing or broken authorization. So if it's not 1, 2, 3, 4, but a globally unique identifier or something that has a lot of numbers, which is kind of difficult or in theory very difficult to guess, but still enumerable and due to brute force possibly hit, is this a valid protection? I always argue no.
I
but
agree
they don't
with
like
you.
the argument.
I'm sorry that they don't like the argument. The truth won't change if they don't like it. But unfortunately, yes, if it's enumerable, you can. That's the same thing as a cryptographic key. For instance, 128-bit encryption, you need 2 on 128 combinations to guess this. I would ask them, how many bits of randomness do you have? Do you have at least, like, if we want to be very easygoing, I would say 64 bits would be kind of okay if you have mitigations in place, but 128 bits would be good. So I would ask them, okay, I do not wish to argue on you, is this good or not? Let's look at the math. So how quick you can guess this? Yeah. How many iterations can I guess per second? Is this offline or online attack? Okay. What is your response policy for how much time do you need to before your intrusion detection, not IDS but any other tripwires you have in place start glowing and you know that stuff is broken? And also, it's always...
How long is valid?
How long is it valid and so on. Let's look at the math. Usually, UUIDs are a good example. People say, you cannot guess UUIDs. How are they generated? What was the seed? Oh, their time. How old is your company? 4 years. Good. That's not a lot of seconds to guess.
Usually the answer is secure random,
We can talk later about a specific occurrence, but I say, if you have enough randomness, 2 on 128, then it's fine, but usually I would say not, and I would agree with you. And also authorization can be enforced easily. You have a cool framework called Open Policy Agent, OPA, it's written in Go, and you can make very cool authorization choices, and you can write your authorization policy pretty easily, and it's awesome to enforce authorization company-wise, and it plugs into the whole enterprise, what you ever have, Active Directory, Kitsar, whatever you need.
Thanks.
Thank you.